So in this question, it says a student expanded the expressions below and made the following statements. So we've got expression f, which is 2x minus 1 to the 4. And expression g is 2x plus 1 over x to the 4. Statement A, the constant term is 24. Statement B, the second term is negative 32x cubed. Statement C, the expansion has 5 terms. Statement D, the first term is 16x to the 4th. So we're going to use the following code to indicate which statements are true for each expression. And so you can see that down there. 1 is if it's only good in expression f. 2 is if it's only good in expression g. 3 is for both, and 4 is for neither. So let's take a look at A here. The constant term is 24. Well, okay, that's not true of f. You can tell by looking at f right now, because it's 2x minus 1, the second term in the binomial is just a constant, it's just 1. When I expand that out, the last term is going to be the constant. Its coefficient would be 4 choose 4, which is just going to be 1. And so it would be negative 1 to the 4 multiplied by 1. That's not 24. Now, but it could be the constant term for g. Now, remember how this works here. So when I expand this out, the constant term is going to be, in this particular case, where the power on the 2x and the power, or the exponent on the 2x and the exponent on 1 over x match each other. So that I've got the same number of factors of x in the numerator as I have in the denominator. So if we start expanding this out, we're going to get 4 choose 0, 2x to the 4, 1 over x to the 0, plus 4 choose 1, 2x cubed, 1 over x to the 1, not quite, plus 4 choose 2, 2x squared, 1 over x squared. There it is. Okay, so right there we're getting the x's to cancel out here. Now we just got to take a look at the coefficient. 4 choose 2 is 6. And then I've got 2 squared is 4. There's my 24. So that's true. So statement A is actually only true for expression g. And so when I look at that, that's 2. Now let's take a look at the next one here. The second term is negative 32x cubed. Well, okay, that can't be true for expression g. And the reason it can't be true for expression g is because there's no negative there. There's no way for a negative to pop out as the coefficient. So let's just take a look at expression 1 here. So the first term is going to be 4 choose 0, 2x to the 4. Now, that is interesting right off the bat here. Now that I've written that down, notice that both of these start exactly the same way. In fact, they're both going to start with 16x to the 4th. Well, that's that last term. D must be true for both of them. So I'm going to put a 3 there. I wasn't even looking for that, but that kind of popped out and fell into my lap there. Now let's go back and keep looking at this expansion here. The next term is going to be plus 4 choose 1 times 2x cubed times negative 1 to the 1. Now let's just double check this. We know that 4 choose 1 is going to be 4. And 2x cubed is going to spit out an 8 as a coefficient. We multiply those together, we are going to get, in fact, negative 32x cubed. So that is true for expression f. Now, let's take a look at expression C, or statement C. Notice that each of these is gone to the power of 4. Well, the number of terms is always going to be 1 more than the exponent. So yeah, these are both going to have 5 terms. So the number that we want to put here is 3 as well. So the answer to this question is 2, 1, 3, 3.